Flooding in the Red River Basin, when you get down in the Lake Plains, the flat areas, and Warren is down in there. They're off what we would call the Beech Ridge Transition Zone. They're about 15, 20 miles into the lake bottom. And spring snowmelt is kind of a challenge in that part of the state. That watershed outlets north to Lake Winnipeg and Hudson Bay. So when our upper end of the watershed, which would be the Warren area, the Fargo area, starts to thaw and starts producing runoff and watershed yield, our outlet's still frozen. So things tend to stack and back up. So township roads are kind of barriers, with culverts being their only outlet. And a lot of times the water comes and melts quicker than the culverts can outlet it. Each section basically holds a lake. But if you happen to be a low area, like Warren, we always used to call it just a bowl. It was very low. So it held a lot of water and deep water, and the only outlet was the Snake River. So when it was backed up for months at a time. We needed to have that bowl area protected. In 1996, they had 3 back-to-back storms, I believe it was, that kind of laid some serious damage to the city, government offices, and the local public school. After that had happened, the town of Warren had steadily seen a decline in population. They were having difficulty keeping folks living there because they were so frequently flooded. The ultimate goal for Warren was to provide flood control to the 100-year storm level. The project started in 2000 and was basically fully functional in 2007. One of the things that we decided to take a look at was a bypass channel around the city of Warren. So how that was achieved, there was a concrete control structure that did go across the channel, but it was designed with the ability to be opened up and basically let most flow go through town if necessary, up to a 2-year storm. Anything larger than about a 2-year storm, you could start to throttle back that structure and force water to go around the town of Warren through this diversion. Well, when that happened, we had some issues downstream where flooding downstream, where the diversion came back into the Snake River, the level of the water surface was higher than what we would have been prior to. So while Warren would have been good, anything downstream would have seen higher storms, and that was a problem. We could not do that to the folks downstream. So to offset that impact, we came up with a solution for an off-channel storage area, what we frequently call the OCS. Because what happens here is that when the Snake River gets to a certain level, high flood water gets shaved off of the Snake River and is held in the off-channel storage area. The off-channel storage area on a 100-year storm will hold around 6,700 acre feet. And then that is held for about 10 days after the peak of the storm is passed, and then they will open up the gates and start drawing down the off-channel storage structure.
The off-channel storage area upstream of Warren is right off the side of the Snake River, and during a flood event, water will rise in the Snake River to the point where it then spills over and spills into the off-channel storage area. And that way we can store a lot of the runoff in there, reducing the peak downstream that reaches Warren. The inlet into the off-channel storage area consisted of a side inlet weir, and there had to be some hydraulics design that went into that the hydraulic engineer was involved with. I looked at some of the energy dissipation downstream of that weir, and then its flow from the weir down into the pool area. The outlet to that was a large Type C concrete drop spillway. The actual design for that structure was done with our structural engineers in Fort Worth, Texas. My part was I was a design engineer involved with the development of the drawings and the specifications and design work of various components of the project. We constructed wetlands inside of the off-channel storage area above a certain elevation that would not normally be flooded. So we went in and we did some scrapes, basically a shallow, very shallow ponds that would be inundated with water and would hold so much water. The construction of the off-channel storage area embankment was a large earth-moving project. And all the soil that was used for the construction of that was obtained from areas inside the OCS, the off-channel storage area. We made sure that was well downstream of any created wetlands inside, more down toward the outlet. And we had to target certain types of soils that we were looking for. Primarily, we had to have clay, but there was a lot of silts also involved with that too, just to provide enough material. Clay is a very much more erosion-resistant soil than a silt, so we made sure that we placed the clay zone on the upstream side of the embankment. That would be on the inside of the embankment, basically, that would be subject to wave action. The height is approximately 20-some feet, and with a top width wide enough to drive on. Then as we go downstream from the off-channel storage area to the town of Warren, at that point, we have a diversion structure controlling the flow into the city of Warren. And that is another large concrete structure. And in that structure, we have a large sluice gate that can be raised or lowered to control the amount of flow that continues on down the Snake River through Warren. We ended up incorporating a hydraulic motor. And through hydraulic means then they can operate the gate mechanism to raise and lower the gate. What's interesting about that structure is the soils in this area are a very, we'll call it a fat clay, just a real greasy, slick clay that doesn't have a lot of strength. So it was a challenge to provide stable slopes to the channel in that area of the diversion structure. And one way we did that was by thickening up our rock riprap that we placed upstream and downstream of the structure. The rock riprap has a higher strength than the native clay, and the weight of the rock and the higher strength was able to give us stable slopes in that area. Incorporated into the diversion structure on the right downstream side is the fish passage. The Minnesota DNR permit for the project specified that fish passage be provided up to the 10-year frequency runoff event. The fish passage was designed for a target species. And for the Snake River, the DNR identified as a target species northern pike, which spawn in the upper reaches of these tributaries to the Red River. The fish passage is comprised of a series of baffles with resting cells in between them. The flow velocity through the baffle openings is designed to be less than the burst velocity of the northern pike. So the fish burst from cell to cell and continue as such until they work their way through the passage. Just downstream of the diversion structure, where after it comes through the sluice gate, we have some, I'll call them like dragon's teeth. They're concrete energy dissipation blocks at the outlet. Causes a hydraulic jump to occur at that point, and we have non-erosive flow. It does not damage the stream downstream of that. But the remainder, the higher flows, they spill over a weir into a floodway that is then routed south of town. Then as you go, we have to take out grade in that floodway by the time we get to the outlet downstream of Warren. So to do that, we have 3 rock riprap drop structures. There's one at the inlet, right next to the diversion structure. There's one about halfway down the floodway, and there's another rock riprap drop chute at the outlet of the floodway where it dumps back into the Snake River downstream of the town. The grade of the floodway itself is determined by velocity and attractive stresses. Of course, the higher flow you have, the higher the velocity, the higher the attractive stress. And we had to look at the velocities before the vegetation was established, which was a controlling factor. Once the vegetation is established, it's easy to have a stable bottom. In some areas, we had to provide a turf reinforcement for the vegetation because the velocities and the attractive stresses were higher than permissible for the native material, the native soils.
So when we take a look at what was analyzed for the whole project, this is the Snake River. Headwaters start in about New Fulton up in here. So this blue area is the area of drainage area that's controlled somewhat through the OCS. and the OCS controls about 56 square miles here. We shave off some of the peak water stored in here. The rest of it continues down the Snake River. And the yellow is what we considered area benefited. Now, through here, most of the benefit is to ag land, crop land. Here's the city of Warren. So that's a huge benefit. Water coming into Warren that isn't contained in the OCS comes down the Snake River, continues to Warren. Right in here, there's a diversion structure that can basically block off the channel and force water to go around the diversion, into the diversion structure around the city of Warren, and then comes back into the main channel about a mile downstream of Warren. We still have a lot of yellow area as benefited, and that's because of the OCS reducing the stage. We still get agricultural benefits all the way. We track them all the way down to the Red River where the Snake River comes into the Red River. So this project flows from east to west. You've got a little bit of southwesterly movement before it turns into a northwesterly.
During the floods of 96 and 97, the whole downtown did flood. So there was just a lot of feel to the residents that there wouldn't be a way of building business and handling business expansion unless there was a change that happened. So the roads that you see around this area were all just covered with water, where you could literally kayak down them in this area of town. When I look at the town, in contrast to what it was before the flooding, there's new businesses that have cropped up around the main street and throughout different areas that really were struggling to decide if they should remain if it was a flooded town. And there were literally some buildings that were needing to be taken down. So those have been replaced with new structures because people are able to invest in a new structure and not worry about its flooding. Around town, related to the flood control project, it's very positive. Growth of the community has happened since then, whereas before people were probably a little more paranoid about growth related to business or their own investment in their home. So once the project was put into place, they really were able to think about the economy differently than they had in the past, and their own personal possessions, where they stored them and what they did with them. There was a lot more opportunity around what you put in your garage, for instance. Before that, you pretty much knew that things in your garage would flood, and then after the flood control project came into play, we watched other towns around us have big floods, and Warren did not. So you could see the plan in action with it actually working for the community, which was really helpful. We really have a sense that you can grow your business and that there's stability around being able to make change and have it not be affected by floods anymore. So some of the businesses probably have made a choice to come to Warren, whereas before it would have been hard to market to them and pull them into the community. There's a few new buildings that came up since the flood, and if the project wasn't in place to have the diversion and impoundment, I don't think they would have chosen to be here, or they would have been very nervous about it, or even just worried about the cost of insurance that they would have to incur. And you know, it's the money out of your pocket for insurance, but I always think it's the wear and tear on you as you deal with the flood, that you just have all of that work that needs to happen.
Installing a flood control project like the Snake River project, it involves many entities. First of all, it's locally led, it's locally driven, so it's the local people who initiated the project. We're always in contact and working hand in hand with the sponsors. In this case was the City of Warren and the Watershed District. The main driving force from the City of Warren to get this project implemented was the mayor, Richard Nelson. We're also working with units of government of the state government, like Minnesota DNR, who was very involved with fish migration in the Snake River, and they had a lot of requirements and dictated what we could build, and they had to issue a permit to us to do these. I think the project was a success, and the one reason I say that is during construction, the off-channel storage area was completed, and we were starting work on the diversion structure. And that spring, they had a flood event. We did not have the project completed but the components that were in place were enough to prevent any major damage, any flooding in the town of Warren. So right there, we already alleviated a lot of damages in town. The city itself was very appreciative of the project going through, and they've been very appreciative of the benefits that have been provided by the project. I'm very proud of the Snake River Flood Control Project and its effect, its benefits on the city of Warren. It was one of the last of our PL 566 projects for the NRCS in Minnesota, and I was very proud to work on it and be associated with it.
I would consider every watershed project that I've had the opportunity to work on a huge success. Why? Because we have provided protection to a large amount of agricultural land and a large population of rural and suburban population. We truly thought that this community, if we didn't get this project done, would be non-existent today. Everybody would have moved out of there, couldn't afford it to live there. It got damaged that often. Now with some of the changes in the rainfall amounts and how severe the events are, I'm even more confident that that would have happened if this project did not go through. This was necessary to save a community.